Alright, it's been recorded. You can refer to the slide that I just shared in the Google Classroom. For today, I don't think you need to answer the attendance one because the answer for quiz is accepted as the attendance. Jadi saya tak buatlah soalan attendance tu hari ni. Because I assume every one of you who answer the quiz, yeah, you attend the lecture today. Okay, concentrate back. I will present now. Okay, I hope you can see my screen. All right. Today we will try to go through about these three strategies of proving. There are many strategies of proving, but we start with a simple one first. Okay, some terminologies before in this chapter. The first one is a theorem. A theorem is a proven, is a statement that can be shown to be true. It can still be false, it can be true. For example, theorem. A prime number is infinite. For example, okay, what is the largest prime number that you can think of? Okay, first of all, this statement, we know that the prime number, list of prime number, the smallest one, 2, 3, 5, 7, 11, 13, 17, 19, 23. The list goes on until 101 is also a prime, until a very large one. It is quite intriguing for me, okay, because the prime number means the number which has only two factors, which are 1 and itself. And interestingly, as the number goes very large, there is still no factors before it. The point is, there is someone known as Euclid managed to prove that you cannot determine the largest prime number because the prime number is like an integer, it's infinite. Okay, this theorem has proven to be true. In the world of mathematics, sometimes the theorem which has proven to be true, but sometimes someone managed to point the inaccuracy of the proof, which at the end shown that the theorem proven to be true to be false. Theorem is just simply a statement, a proposition that can either be true or false. But for this one, for the time being, for this theorem prime number is finite is still deemed to be true. And again, okay, I start with another simple one for you to realize. A sum of two odd integers is even. Okay, at this time being, maybe some of you try to think, is this statement true? Sum of two odd integers is even. Most of the students will start with taking two odd integers. A, B equals to 5. Two odd integers. 3 is odd, 5 is odd. And A plus B, the summation is 3 plus 5 is 8. And 8 is even. And then you say, this theorem is true. Unfortunately, if you put your proof, this is actually a proof, but this is an incomplete proof. Because if you want to show that the sum of any two odd integers is even, you cannot prove by cases. You just show that 3 plus 5 equals to 8. 8 is even. How about 3 plus 7? How about 3 plus 101? How about 3 plus 10001? Is it even? And again, if you want to prove in terms of a very general statement, it must be in a general form. Matrix yang pertama tu, saya pernah tunjuk kotak yang pertama. To prove for all, you must really mention for every cases. That is what you will learn today. Okay, there is also a proposition, less important theorem. Sometimes called proposition. Mathematicians rarely use this term, proposition, they use theorem. Lemma is a less important theorem that will help to prove the major theorem, the main theorem that you will prove. You will not encounter any lemma in this subject. During my years as a mathematical science student, I encountered lemma many times. Corollary is interesting, it's a byproduct. Sometimes when you want to prove a theorem, you accidentally provide another knowledge of theorem. Ini pun saya pernah terjadi kepada saya. Saya nak prove theorem A. On the way nak prove theorem A, I accidentally prove a new results that becomes another theorem. We call it as a corollary. Again, lemma and corollary you will not found in this subject. If you're a mathematical science student, then you can see those. But for you guys, you don't see that. A conjecture is an unproven theorem. Okay, you have the laptop and your smartphone with you right now. There's a Millennium prize problem. Kejap. 7 Millennium prize problem. Okay. It is given by Clay Mathematics Institute. I think it's in US, I think. Institute. This 7 problem is considered a major conjecture that should be solved. It's an important topics in mathematics that should be solved, because if we manage to solve it, it can change the whole paradigm of science in the world. Okay, from these 7, 1 has been solved. The Millennium prize problem, if you prove or disprove any one of the Millennium prize problem, you are entitled to get the prize, which is USD 1 million. Okay, nak saya tunjuk ke? Ke korang malas nak search? Saya tunjuklah. Okay, Millennium prize problems. Okay, you can read it on Wikipedia. These are 7. The one that I really interested in is P versus NP and also Riemann hypothesis. One has been solved, which is a Poincare conjecture. Okay, ni tak payah hafal saya kongsi pengetahuan This is a general knowledge. A Poincare conjecture has been solved in 2003 and you have remaining 6 yet to be solved. So 6 million USD up for grabs. Okay, kalau you nak kaya cepat, solve lah salah satu problem ini. But again, I don't think this 1 million is sufficient. Sebenarnya problem yang diberikan ni is worth 1 billion, seriously. Okay, Poincare conjecture. It's a very hard to understand, even for me. But it has been solved by a Russian, this guy. Gregory Perelman. Inilah muka genius yang menggenggarkan dunia dalam menyelesaikan masalah matematik. Apa ni? This guy. Tengok. And interestingly enough, this Gregory Perelman, this Russian, declined the price. He don't want the USD 1 million price. Apa pendapat you all? Dia tak mau 1 million tu. He's doing it for science.
Dia tak kejar title.
Dia tak kejar title. Wow, ya. Dia tak kejar title. Betul Musin. Okay, bayangkan satu hari lah saya tanya soalan hypothetical. If Musin manage to solve any of the Millennium Prize problem, you dah dapat, you boleh layak dapat 1 USD tu, you tolak ke tak? Tak tolak. Kenapa?
1 million tu siapa nak tolak?
Tapi kenapa dia tolak?
Apa?
Saya sampai sekarang tak boleh brain benda tu. I cannot think the reason dia yang dibagi looks noble enough. He's doing it for science. But dia dah kaya. Okay, Arisa. Kalau dia dah kaya, kenapa muka dia macam tak tahulah, tak terurus lah saya tengok.
Passion dia kan.
Pun tak mau. Nak pergi apa tu? Hair salon, buatlah shampoo rambut sikit, buat rebonding sikit pun dia tak mau. Saya tak rasa dia kaya lah. Actually, if you read about Gregory Perelman, he still live with his mother. He's unemployed at the time that I read about him lah. Dia dah lah tak bekerja. Tapi tak apalah, pelik lah. He's passionate about career. He's a very interesting guy. Okay, the thing about the 7 Millennium Prize problem, once he has already solved it, dia punya proof tu setebal buku ini, memang tebal. Saya baca, ya Allah, tak faham lah dah lah, tak faham, tebal pula tu. It requires 2 years for the world of mathematician to read about it and to disprove his theorem. To disprove his proof lah. Dia ada proof dah, dia dah buktikan 2 tahun diperlukan untuk mencari kesalahan proof tersebut. Dan the 2 years has already expired and most mathematician, majority of them accepted that the proof provided by this guy to prove about Poincare conjecture is true. Okay? Why I like about P equals to NP? Muka dia ni lagi. Alright, P equals to NP, saja saya nak share lah kenapa saya minat P equals to NP ni. P equals to NP is a really important problem in computer science sebenarnya. Dia mathematics and also computer science. And also Riemann hypothesis, if you combine P versus NP and Riemann hypothesis, theoretically every password in the world can be cracked within a matter of minutes. Password susah nak crack. You punya password. Kita ada komputer super duper komputer yang laju untuk mencari, untuk crack kamu punya password. However, if this theorem managed to be solved, it means benda tu macam mana saya nak cerang. Benda ni agak theoretical for you guys. Saya cuba explain dalam a layman term. Okay. Password yang complicated memerlukan masa bertahun-tahun untuk selesaikan. So make sure your password is very strong. Consists of a combination of alphabet, numbers and also symbol. Even supercomputer also have a very hard time, maybe from the 100 years become puluh-puluh years untuk menyelesaikan crack your password. Tetapi if P equals to NP, it means that it can be solved one day later. The password cracking can be done in a matter of seconds. Bagi saya interesting lah. You rasa tak ke? Saya tak tahulah kan. It means memang dalam kriptografi dia akan memberikan apa tu, satu paradigm change. Okay. Kalau P not equals to NP, that's fine. Saya pernah jumpa satu profesor daripada US saja sembang dengan dia lah. Apa pendapat you pasal P because MP ni? Sembang dengan dia lama pasal benda ni. Tapi we all rasa lah tak akan dapat solve lah. Problem tu sangat susah untuk di solve. Okay. We don't talk about password cracking yet until number theory nanti. Number theory nanti chapter 3 kita akan masuk sikit pasal cracking of the password. Okay, we go back. Cukuplah pasal isu USD 1 juta tu yang saya tak akan dapat lah. Alright. Now we try to learn the essence of proving. Just now I show to you this theorem. Okay, I will start with a simple one. The sum of two odd integers is even. And just now I already explained to you that if you prove by cases, that is not the actual proof. Your proof is incomplete. How to generalize the proving? We start with a definition. When I ask you, what is odd integers? Give a definition of odd integers. If I ask my student and also my friend, Bazli, odd integer tu apa Alah, odd integer kau takkan tak tahu. 1, 3, 5 is integer, 7. And then, if you think the statement very clearly, is that statement general enough? Saya boleh tanya Dr. Bazli balik. 101 odd ke tidak? Odd lah, takkan kau tak tahu. 103 odd juga. How about 1001? Pun odd juga. How to make sure we define odd integers not by cases but into a general term. That's why, okay, definition of odd, like the slide on the left show. The integer is odd if it can be represented as 2k plus minus 1. Minus 1 also can, plus 1 also can. It's 2k plus 1 and that k must be integer. Pendek je, general. So just now I asked, is 101 odd? 101 is odd. If it is odd, then it can be represented as 2k plus 1 and this k must be integer. So 101 equals to 2 times 50 plus 1 and 50 is definitely an integer. Therefore, guaranteed that 101 is odd. Ini contoh. This is an example and this is actually the general definition that I state just now. N equals to 2k plus 1 comprises of every odd integer in this world. How matter small it is, how matter large it is. This is odd. So, if the number is not odd, we call it even. And even is n equals to 2k and k is an integer. So two definition that we will use today is 2k plus 1 for odd integers and that k is in integer. Even is n equals to 2k, k is also an integer. There are several methods of proof that you will learn in this topic. For today, I think I will cover direct first lah. Yang dua lagi tu tengoklah kalau ada masa lagi ke. Okay, direct method. Okay, direct method stems from this idea of argument. P implies Q, P, the conclusion is Q. This is type of argument is also known as modus ponens, the method of affirming. So basically, this kind of argument, P implies Q, if P then Q, P the conclusion Q. You assume that P implies Q is true. You prove that P is true as your conclusion. As your conclusion, Q is true. Hence the word method of affirming. So suppose I repeat back the theorem that I want to prove. If X and Y, if X is odd and Y is odd, the same question actually, but different way of presenting it. If X is odd and Y is odd, then X plus Y is odd. Alright, so you dah belajar logik, apakah dia P, apakah dia Q. Okay, in this sense, P, X is odd and Y is odd, implies Q, X plus Y is odd. Ini soalan lain. Nantilah kita buktikan yang kiri ni. Focus on the one on the right first. Saya tak buka lagi soalan. Nanti kita buka soalan. Alright. Now, we need to assume first, we assume that this statement is true first. We believe that if X and Y is odd, both of them is odd, then we assume that X plus Y is odd. So P implies Q. So the first step, the proof starts now. We let X be 2k1 plus 1, and this k1 is integer. Because I believe X is odd, therefore X can be represented as 2k1 plus 1. And because Y is also odd, Y equals to 2k2 plus 1. K2 is also an integer. Okay, so what will be X plus Y? X plus Y equals to 2k1 plus 1 plus 2k2 plus 1. You open the bracket, it will becomes 2k1 plus 2k2 plus 2. Okay. For the time being right now, when you look at this representation, 2k1 plus 2k2 plus 2, adakah ini bentuk even integer?
Yes.
Are you sure? Even integer macam mana tadi bentuk? Even macam mana?
Even 2k.
2k. Adakah ini 2k?
Oh tak.
Adakah ini 2 times something? Belum lagi. It's not there yet. My point. But it's okay. How to show this one becomes a multiple of 2? You can show it. The first idea here, you factorize this thing, becomes k1 plus k2 plus 1. Okay? You factorize 2, the idea there. Then 2, this one k becomes k1, k2 saya ambil lah jadi 2m. This m is represented as k1 plus k2 plus 1, and this m is an integer. Okay. K1 integer, K2 is integer. Definitely 1 is also integer. integer plus integer plus integer becomes m. M is also an integer. So at the end here, nanti saya buka soalan, sabar dulu. I can represent x plus y becomes 2m, 2 times something, 2m. This m is an integer. Right now, I guarantee that x plus y, if x is odd and y is odd, you sum it up, it can be represented as the multiple of 2, 2m, or 2 times something. That something is an integer. So, I just managed to prove to you guys that if x is odd and y is odd, then the summation of x plus y definitely will be even. So I assume if p then q, I show the p. The p is that x is odd, y is odd. I try to sum it up. The summation will be 2m is true. The conclusion is q. I just prove that if x is and y is odd, the summation is even. This is the way of direct method. Okay, saya buka soalan. Nanti saya akan tanya soalan kepada kamu balik. Update masa nak Adam. Ada soalan boleh tanya sekarang?
Boleh bagi tahu elemen yang kena ada untuk proof. Macam kena ada apa, assume, lepas tu yang bawah-bawah tu.
Elemen apa tu? Saya tak faham.
Yang macam saya kata yang macam yang apa dalam Microsoft Word tu, kan ada let x equals to 2k plus 1, let y equals to 2k2 plus 1 kan. Itu macam assume kan. Lepas tu step seterusnya kena buat macam ni semua tu.
Okay. I try to answer what is the Muslim's concern as best as possible. Actually, Muslim, it depends on the statement. For example, this is about the summation. Kalau summation, kita tunjuk tambah. Tetapi proving is not only about the summation of the products only. It can many kinds of proving. Dalam chapter logic pun ada proving. Proving apa tu? Chapter yang kita dah belajar tadi, logic minggu lepas dan Selasa baru ni, kita pun ada proof. Proof apakah itu? Kita ada proof equivalence. We have the proof to determine valid or invalid argument. Setiap nature of the content, the way of proving is different. But the idea, the strategy is almost similar. So I want to recap back. For example, you already use it in your quiz just now. Prove that P is equivalent to Q. Okay? Equivalent means that if the biconditional between P and Q is tautology. Definition dia. Okay. So you buatlah truth table. Truth table tu adalah salah satu cara untuk prove. Then at the end you manage to prove that P biconditional with Q is tautology or not. I tak tahulah apa jawapan dia tadi. I tahu tapi that's not the point. At the end you conclude it's equivalent or not. Elemen yang kena ada ialah yang secara asasnya, the most basic form, you is better start with a definition first. Definition. To define what is even, what is odd, what is logical equivalence. Kena ada. As a basis for your proof. Okay? And depends on the statement that you need to prove. Macam soalan ni, summation, you sum it up. And then you finish with the conclusion. Setakat ni, basic idea dia, definition, proof structure dengan argument, premises 1, premises 2, depends on the creativity of the provers, yang orang yang nak prove tu, and you end with the conclusion. There, I cannot say that for every proof, listen carefully, every proof it must be the same structure. For example, for this question, the sum of two odd integers will be even. Ada setengah mathematician dia tak nak guna cara ni. Ada setengah student saya dia tak nak guna penjelasan ini. They don't want to use this kind of argument. That's fine. They can use other kind of strategy of proving. Ada, tak ada masalah asalkan dia general. The one that is wrong is the proof by cases. It's incomplete. Untuk soalan ini, okay, saya clear jawapan ni ingat Okay, if I get a student for the same question just now, prove if X is odd and Y is odd, sorry, X plus Y is even. If they prove it like this, let X equals to 7, Y equals to 11. Because 7 and 11 is odd. X plus Y becomes 7 plus 11, becomes 18, 18 is even. So, proven. This is also premises, ada definition dia, definition of X and Y, summation dia punya, tambah, and then the conclusion. But, like I said, this is a proof, but this is incomplete proof. Cara dia tidak lengkap. Direct method menggunakan kaedah idea struktur yang hampir sama dengan apa yang saya present tadi. Indirect method cara yang berbeza. Okey, saya harap buat masa sekarang cukup dulu yang saya cakap tu untuk bagi idea kepada musim. Lepas ni kita akan tengok lagi contoh lain. Kenapa bukan 4K2? Ya. Oh, ya. Dia bukannya 4K2 Alia Nabila sebab dia dua variable berbeza. Okey. Oh, tambah sorry ingat tak. Okey. Now we back to the previous one. Why there exist K1 and K2? Ni menarik. Sebab ada sesetengah student soalan yang sama lagi Okay. This is another example of incomplete proof. Let X equals to 2K plus 1 and Y also I put 2K plus 1. There is no K1 and K2 there. And then the student letaklah X plus Y, 2K plus 1 and 2K plus 1. Saya cuba tengok apa yang Alia cakap tadi tu. Sebab ramai student buat kesilapan yang lebih kurang. Bukan saya kata Alia buat silap, saya kata you punya senior banyak buat silap. 4K plus 2 becomes 2K plus 1. Okay, jadilah 2M. This M is kejap, saya buat salah ke? Tak. 2K plus 1 and this M is also an integer because K is an integer. So 2K is also integer. Integer plus integer becomes another integer M. Alright, so for this one it conclude proven X plus Y is even. Okay. Saya nak tengok ada tak student yang boleh jawab ni. Kenapa ini merupakan incomplete proof? Before I answer, I want to see is there any of my student who can detect what is wrong with this representation. Dia menggunakan K yang sama. Apakah masalah dia?
Saya rasa
apa yang kamu rasa?
Sebab apa ni, kalau kita ikut definition, kalau untuk contoh X tu, untuk definition untuk X, K dia nilai yang lain. Untuk Y, K dia nilai yang lain. Benda yang berbeza.
Okay. So apa yang problem dengan soalan? Apa dengan problem dengan proof ni?
Dia buat satu nilai je K.
Kurang. Tak sampai, dia tak sampai. Punchline tu tak sampai. Okay. Ada dalam... Okay. Leong Tengman dah jawab. Dia jawab dalam chat. Korang boleh tengok jawapan dia. Okay. Betul lah, dia K yang sama. It's the similar K. In this case, X is always equal to Y, so it does not generate enough. So, Leong, you are correct. What this proof just show is that this proof shows, saya ulang, that the sum of same odd integers is even. The same one. Dia kena sama. Dia paksa X dengan Y tu sama. The summation of two same odd integers is even. That's why dia tak general enough, dia tidak sempurna, dia tidak complete. The previous proof, by using different K, K1 and K2, it can be same, it can be different. So the statement, the proof is much more complete, encompasses of every odd integers out there. That is why there is a different K there. Thank you. Alright. Kita teruskan untuk soalan yang lain pula. Untuk chapter ini saya nak kamu berfikiran luas. Maksudnya kita nak buktikan untuk kesemua possible cases, general one. We still on the same topic of even and odd. Let's look at this question in the slide. Prove that if X is even. Dia tak ada X plus Y dah. Dia tak ada dua. Dia satu je. Prove Allah. If X even, then X squared is even. Okay. Only one integer. But it states that if the integer is even, then the square, X squared is even. Okay, for some student, sometimes before they get the idea to the actual proof, it is no harm for you guys to visualize the statement. Contoh, ini bukan proof tapi dia nak visualize. Let X equals to 4. Dia nak tengok what is this theorem state actually. You take 1x which is even, 4 is even of course, and x squared is 4 squared equals to 16. 16 is also even. Like I said, this is not a proof, but it's a good way for you to visualize. Oh, ini yang dia nak. This is what they want. They want to show that even x squared jadi even. Okay. Now goes to the actual proof. Okay, let X be even. So X equals to 2K, this K will be integer. There is no another integer. So it's okay for you to use just K. Tak perlu K1 and K2. Satu integer saja. What is X squared? You take everything inside here become squared. You proceed, it becomes 4K squared. Right now, I managed to show to you guys is that if X is 2K even, X squared will be a multiple of 4. 4 times something. Multiple. However, the definition of even number is not a multiple of 4, it's a multiple of 2. So usually, I will factorize this become 2K squared. Becomes 2, lepas huruf K, L. Boleh tak saya guna L kali ni? L. You nak guna huruf apa pun tak ada masalah, tak ada masalah sebenarnya. You nak guna A, B, C, X, Y, tak ada masalah. It's algebra juga. Okay, so this L is equivalent to 2k squared, and because k is an integer, k squared is integer, k squared times 2, 2k squared is also an integer. This L definitely an integer. Therefore, x squared can be represented as a multiple of 2L, that L is still integer. So I proven to you guys that if x is even, x squared is also even. Okay, you can compare with the slide yang kat sebelah ni, sama je. The gist is the same. Okay, I open to any question. Ke dah tidur? Belum Okay, I want to test you guys with another question. Alah. Saya tak tahu soal ada dalam slide ke tak. Sekejap. If x and y is odd. Okay. Soalan ni tak ada dalam slide. Okay. I want to see if any of my student can prove this. Prove if x is odd and y is even. If x is odd but y is even, then the multiplication, the product between x and y is even. Can you prove this? Kalau dah dapat, please voice out your answer. Atau I nak tengok you punya jawapan. Dalam WhatsApp tak apa, dalam mana-mana pun tak apa, saya nak tengok. Please prove this. In 3 minutes. Saya tak faham soalan you, Tengman. If x is even, then xn. Ini soalan lain. If x is even, then x to the power of n, right? You cakap. Tadi soalan tu x to the power of 2. Kalau if x is even, then x to the power of n. Itu soalan yang menarik. Saya boleh tanya kot time assignment. Boleh? Itu menarik. Saya tak pernah tanya soalan tu. But right now, I want to ask a simple question first. So, Tengman, please answer this. Sebab if you involve any n, you need induction there. Mathematical induction. Okay, saya nak kamu, mana-mana student, jawab soalan ni dulu. Ni soalan basic. Soalan ni level quiz tau. It means that every one of you should be able to at least derive the premises and argument to show the proof to me. Oh yeah, by the way, proving is the hardest content for this subject. Logic paling senang, proving paling susah. Chapter lain lepas ni insyaAllah senang lah. Sederhana. So survive this thinking first. Saya tunggu Saya nak soalan ni student jawab For this question, I want my student to answer. Sebab Dr. Zana cakap batch korang ni pandai, saya nak tengok pandai. Saya nak tengok kepandaian tu lah. Dia yang cakap. Saya memang nak semua student saya pandai. Tak ada student yang bodoh pun. Student yang malas dia ada. Dan adakah kamu malas jawab soalan ni? Kalau tak, cepat. Korang tunjuk kat mana? Is there K1 or K2 or just 1K only? Think first, I don't want to answer. Like I said, student answer first. Ada yang dah jawab? From Jiajin. Okay? Jiajin, your proof is incomplete. Your algebra is correct, but for your explanation, maybe I minus 1 mark or even 2 marks. Bergantung pada the portion of the marks. But it's interesting to discuss as well. We try to make it as general as possible. Okay, Imran Khairul menjawab di sini. Dia tak suka guna K, dia suka guna M dengan N. No problem, Imran. Okay. Apa ni? Sorry, kamera tak jelas. Apa ni? Okay, enough. Thank you for the contribution. Aifel hantar, Musim hantar, Imran hantar, Jiaji hantar. Thank you guys. Yang lain boleh stop dulu. Because I want to evaluate. Okay, komen saya Imran, your proof is complete Imran. Aifel, please be careful with the bracket. Hati-hati when you want to represent the product, make sure ada bracket lah. Kalau tak ada bracket kita boleh cuai Aifel. Next, Musin macam Imran jawapan. So still the proof is complete. Okay, thank you so much for the contribution. My student managed to answer. Some of my student managed to answer it very well. Okay. So saya tak perlu balik tulis jawapan tu. You boleh tengok jawapan kawan kamu. Betul. Tanya. Okay. Now, we might go to the last question, for example. For today, it's been a long day for you guys. Alright, contoh lain. Ni you boleh tengok, ni kita dah jawab tadi. Alright. Last question for today. Sebelum korang henti lunch. Okay, this question is like what Musin asked just now. Atau lain, saya tak saya rasa lah dia masukkan benda ni. Elemen yang penting. Okay, every statement sometimes the requirement is different. For this question is that if there are two integers, interesting enough that this question does not involve even and odd. It involves perfect square. So for the students who happen to not know about the perfect square, definitely they cannot answer this question. Tetapi perfect square you all sebenarnya sudah belajar. Just you don't know how to put it into a definition. Okay, to recap, what is perfect square? Example of perfect square. Satu, adakah dia perfect square? Kenapa nama perfect square? Square, the length of the side is the same, D equals to D. The name perfect square because it implies that this D square, then this D is integer, hence the name perfect. Square memanglah length sama, tetapi perfect tu implies the integer. So 1, can it be represented as D squared? You can. 2, dia jadi square root 2 squared. So dia bukannya perfect square. Dia square tapi dia tidak perfect. So what is the next perfect square? It will be 4 because 4 can be represented as 2 squared. Then you happen to know that the 3 squared, 4 squared, 5 squared. So 1, 4, 9, 16, 25 are the examples of perfect square. There are infinitely many perfect squares. Okay. So to generalize the statement, the definition of a perfect square can be represented as k squared. K is an integer. So n, suppose n is a perfect square, n is k squared, k is an integer. Inilah general definition yang patut kita guna. Okay, the proof starts now. Okay, A and B are both perfect square. So saya gunalah A sama dengan K squared. K is an integer. Saya ambillah B equals to L squared. L is an integer. The question requires you to show that the product between A and B is also perfect. So A times B becomes K squared times L squared. Open the bracket, it becomes K squared L squared. And it can be simplified as KL squared. As K is an integer, L is an integer, it can becomes M squared. M equals to KL, M equals to, M is an element of integer. So A, B can be represented as M squared such that M is an integer. So I just proved to you guys that proven if A and B are perfect square, then AB is perfect square. So elemen yang kena ada again for Musin punya soalan, definition, the proof and the conclusion. Proof without conclusion is not complete. So every time you write your proof, make sure you write proven. Okay, proven of what? What do you prove? What do you prove just now? is this. For you for your level, all the theorem in the question is actually already true. Saya bagi tahu balik, saya ulang balik, I repeat back. For your guys punya level, all the statement given has already been true for this module. Maksudnya you tak akan dapat proven otherwise. Disprove, tak ada. Semuanya straight to the point. If it says that both perfect square integer also perfect, AB, maka betul dah. Jangan tiba-tiba at the end, you cakap not proven. That one is for another level. Right now, every question that you get for your assessment is assumed to be true. Okay? Alright, to recap, ada soalan tak sebelum saya tamatkan sesi kuliah pada hari ini? For 1 minute to recap, to relax, fikir balik apa yang nak ditanya. Soalan Leong ni saya nak simpan mungkin saya boleh guna satu hari nanti. What Leong asked is that prove if x is even, then x to the power of n is even. That n is an integer. To visualize what Leong asked is that, suppose this is not true, let saya ambil lah x sama dengan 6 6 kuasa 1, 6 kuasa 2, 6 kuasa 3 definitely will be even. Dan n, any integer. So saya letaklah 6 kuasa 99 pun dia mestinya even. Itu claim beliau. Dan saya rasa ini teorem yang sebenar. Tetapi kita nak proof yang ni, kita tak boleh guna direct method. Dia kita guna induction. K1, K2 senang confuse. Apa ni? Is there K1? Kalau I add terpulang, you can choose any alphabet like I said. As long as it's different. K1 dengan K2 berbeza. Tadi siapa buat tadi? Dia buat M dengan N berbeza. Tak ada masalah. Kalau you senang confuse dengan K1, K2, I don't really advise you to use that. You use just a different alphabet. Okay? And ada soalan lain setakat ni? Okay, if you don't have a question, have a good rest. I think you have class. Ada kelas tak lepas ni? Do you have any other lecture after this?
Tak ada.
Tak ada dah? Cancel? Kuliah apa yang cancel tu Hafiz?
Kelas intro intro data.
Oh, Bazli, kuasam. Bunuh.
Tak, anak dia tak sihat, sir.
Saya tahu. Dia ada beritahu semalam. Semalam dia tidak datang, anak dia tidak sihat. Oh, so cancel lah. Okay. So sama-sama lah kita doakan anak beliau dengan korang semua sihat lah. Tak ada yang tak sakit, yang tak sihat lah. Alright. See you guys for another session. Sekejap. Kita nak asing ke minggu depan? Selasa. Tak nak apa Akram? Tak nak asing? Alamak. Boleh je. Nak kelas macam ni. Okay, Akram dengan siapa? Okay, kenapa Akram, kenapa ada asing? Saya jelaskan dulu lah. Nanti saya akan decide lepas ni. Asing tu maksudnya you belajar sendiri. You tak ada live session. Itu maksudnya Adam. Macam saya cakap, okay, jangan buat poll lagi, jangan buat poll lagi, nanti dulu. Sebab asing adalah nak menjimatkan kuota sebenarnya. Because live session involves much more data. That's all. Dan mungkin kalau saya nak buat kelas synchronize pun, sync boleh, tetapi saya tidak wajib. Boleh je, saya tak kisah pun. As long you belajar, okay? Nanti kita decide. Saya akan share video YouTube saya berkenaan direct method kepada kamu semua lepas ni. Alright? Have a good rest. See you guys for next week. Okay? Bye-bye. Assalamualaikum warahmatullahi wabarakatuh and good afternoon.
Terima kasih, sir.
Thank you, sir.
Thank you.
Thank
Bye-bye.
you, sir.
Thank you. Bye-bye.
Okay, sir.
Thank you, sir.
Okay.